called the independent coordinate. Is there any doubt on that? You gone through that? Where I kept this? Is that the word file is visible to you?
Yes, sir.
Okay. Yeah. So look at the last coordinate. You just corrected coordinates that completes the table actually. So what is that we do is we fix up a point so that all the other coordinate, because we arbitrarily choose a value, larger value, and then you see that it comes in the first quadrant with the north and the east. So I assign 200, 200. 200 is the latitude, north, and 200 is the east. That is the coordinate arbitrarily have been assumed to point A. So if you look at it, corrected coordinate is 14.42. 14.42 plus 14.42, it becomes 214.42. 200 plus 200 to 248.86 become 448.86. Then the south coordinate comes 214.42, 122. Is it correct actually? 214.35. Anybody check it out? Yes, correct. So you know how to assign the coordinate system now. Okay. This is the way how coordinate system has been assigned to where. So finally you get all the things in this thing. You can find out any Traverse plotting become easier. So this is the analytical way of solving the problem. This table is called a Gale Traverse table. So you should be in a position to find out the other this thing. When you look at it yesterday morning when we started it, there was nothing in the table. Now we started filling up. The table has come to a full state now. So we'll assuming that there are no doubt, we'll go on to the next aspect of surveying. What is that? Yeah. Right. The traverse. We have seen a open traverse, closed traverse, everything. Now, at time what happens? Some part of it, when you are proceeding with a closed traverse, some of the measurement you would not have taken it. You would have some obstruction should be there, and then you would have come back actually, right? So that is the case. For example, if I say that this is what is called the omitted measurement. Okay, omitted measurement. Okay, right. Just go to this. So what happened? A, B, C, D, E. A is a pentagon. 1, 2, 3, 4, 5 sides are there. And this phi side, suppose I say that some measurement is, I have not taken it at EA, I have omitted the measurement. Either I could have, I have not taken a bearing, or I have not taken the length of the line. Anything can happen, no? Right. How do you solve the problem? How will you solve that? Anybody? Because surveying is the application of geometry. I just leave it to you. How we are going to solve the problem here? How will you solve the problem?
Sir, the departure and the length of, like, those lengths we can find, sir, using that sigma L equal to 0 and sigma D equal to 0.
What is that? Suppose I say that length of EA and bearing of EA has been omitted. How will you solve the problem? What you say is correct. Go ahead, please. So what is the theory says that sigma L is equal to 0. So latitude of AB, latitude of BC, latitude of CD, latitude of DE, latitude of EA equal to 0. So what is the latitude of EA then? What is the latitude of EA?
A cos theta.
Sigma L is equal to sigma L equal to 0. So that sigma L equal to 0. So latitude of AB cos theta plus BC cos theta plus CD cos theta plus DE cos theta, where theta is the whole circle bearing. It is not a reduced bearing. Okay, whole circle bearing. And EA cos theta is equal to 0. What is EA cos theta? EA cos theta is minus of sigma L. Am I right? Minus of sigma L. Is that not?
Yes, sir.
Yes. What is the departure of EA?
The sine theta components, sir. Sum of all sine theta.
Sigma D is the departure of each line. Sigma of D equal to 0. Sigma of D is equal to 0. So what is departure of EA?
The sum of sine theta components,
minus
sir.
sigma D, isn't it? Minus sigma D. So minus sigma D minus sigma L. Minus sigma D is positive. Minus sigma D is positive. Minus sigma L is also positive. Which quadrant EA lies?
First quadrant.
Minus sigma L is positive. Minus sigma D is positive. Which quadrant the line EA lies? Both are positive, boys.
First quadrant, sir.
First coordinate, na? North and E. Do you get a point? Okay. North and east. How will you find out a bearing?
Sir, tan theta equal to latitude by departure. We can find the bearings.
Latitude by departure. Tan theta equal to?
Departure by latitude, sir.
Departure by latitude. Tan inverse of departure by latitude. Am I right? But the sign
Yes,
convention, you can fix which quadrant it lies. Depends upon its whether it is negative or positive. Suppose I say that latitude is negative and departure is positive. Which quadrant it lies? Latitude is negative, departure is positive.
Second quadrant.
Second quadrant, southeast. Both are negative.
Third.
Third quadrant. Latitude positive, departure negative, it lies in the fourth quadrant. Okay, so any angle theta vary from 0 to 90 only, because when you do this trigonometrical, the tan inverse of that, it can theta can vary only from 0 to 90. Then you have to find out only the reduced bearing part of it, you will be finding out, but you have to correct it to what is called the whole circle bearing. Is it clear, all of you? So we'll go to the next slide. Latitude of affected side is minus sigma L. Okay. Latitude of affected side is minus sigma L. Departure of affected side minus sigma D. So what is the length of the side? Length of the side. Length of the side. This is Pythagoras theorem only, no? Because it is a diagonal. Here is the diagonal. So you have got your departure as well, you have got latitude. So the projection of the, suppose you say that this is your this thing, so you will get theta over here, no? Right. So what is that? The length of the affected side is sigma d square plus sigma L square root of it, because the minus you are squaring out, you get a positive only. Minus omitted the minus actually. Minus of sigma d. When you square it, it becomes, that is why you got what is called suppose you have a curve. Many points are there, x and y. Suppose you have a x1, y1, x2, y2, x3, y3, x4, y4 and so on. Okay. What is the best curve? The curve of best fit. Any idea? Have we studied curve fitting? Curve fitting?
No, sir.
No. In a high school they don't teach you regression and all. Suppose I have y equal to, what is the equation for a straight line? Analytical geometry. Y equal
Y
to
equal
mx
to
plus
mx
c.
plus.
Mx plus c. Suppose I want to fit a curve with a scatter of point x1, y1, x2, y2, x3, y3, x4, y4 and so on. How do you say that the curve is the best fit curve actually? Something like this, you know.
It passes through most of the points.
Suppose this is a curve, this is a ordinate. See, x and y are drawn, na? So I have point, na? Something like that, you have got a point, 3 points are there. You are able to see that? So I have to fit a curve. Okay. So I can have also points like this, you know. let's look. So I have to draw a curve. No, the curve. This is the curve. So I have a point. 3 points are there, and I have put a curve. Now you tell me, is a curve is a best fit curve? It doesn't pass through all the points.
So you take the square of difference of the y coordinate of the point and the line. If it's close to 0, it will be a suitable curve.
Just put more points like. Is that a best fit curve? Can you look at the figure and say, is it a best fit curve? What is the criteria? What is the criteria? So these points, y equal to mx plus c, this is the line y equal to mx plus c. So m is the slope of that and c is the intercept. Now I got point x1, y1, x2, y2, x3, y3, x4 and so on. And then when you say that it is a best fit curve?
So when the data points match the curve, sir.
When the data points?
Match with the curve.
It doesn't match, this curve, this doesn't point through it doesn't pass through the points, Can you say that it's the best, the curve is a best fit curve, it passes through all the points?
Yes, sir.
Huh? In that
Yes.
case, the curve will start from here, it come here, it come here, it come here, it's here, like that. Okay, right? Now, the method of least square says that a curve is said to be a best fit curve if the sum of the squares of the residual is minimum. Do you understand that? If the sum of the squares of the residual is minimum. Suppose I say that this is the best fit curve. The deviation of this point with respect to the curve is above the line. So can I take it as a positive? Then it's R1. Then this point is also above the line. So positive R2, R3. Then R2 is negative. Then this is negative. Then it's negative. Suppose you add all residuals R, if it is equal to 0, then it is not a best fit curve. The method of least square says that sum of the squares of the residual. Why the sum of the squares of the residual?
Sir, we may have positives and negatives.
So negative, if we square it, what will happen? The magnitude increases. Do you understand that? Magnitude increases. That is why the method of least square says that y is equal to mx plus c is the curve is said to be a best fit straight line if it obey the method of least square, which says that the sum of the squares of the residual is equal to 0. So sigma r square is minimum. So sigma r square, how will you find out the maxima and the minima? Suppose I say that y is equal to f of x. How will you find out the maxima or minima? How will you find out the maximum? Whether the function is a maximum or a maxima or a minimum. So you find out the first derivative of it, equate it to 0, solve for x, find the second derivative, substitute the value of the x in the second derivative. Suppose you get a negative, then it is called a
Maxima.
maxima. So maxima, minima you have studied now. I studied long back. I am not good in mathematics. Right. Similarly, So sigma r square is minimum. So what is that? If you do sigma r square, dou r sigma r square by sigma dou of sigma r square by dou m. M is a variable over here. So you become 2r dr by dou m equal to 0. When you solve for it, you will get a objective function. So that solves the problem. So why I'm telling you all this thing is, when you have got a negative d square and it become a positive, the square root of sigma of d square y plus sigma of l square is same as minus of sigma d square and minus sigma of l square. So if you square it and take a square root of it, you get the length of the effective side. What is the bearing of effective side? Bearing of affected side is tan inverse of minus sigma d by, sorry, I made a mistake. It should be the cut and paste technology always, that is the problem. Is that okay? No. Right? So you can find out what is the theta and then solve for this. So one side is affected. If one side is affected, what do you get? You are able to solve the problem. Suppose two sides are just affected. Okay? Two sides are affected. Suppose DE and EA are affected. You are not taken, either you have measured the length of DE and length of EA, or you have measured the bearing of DE, length of EA, omitted bearing of EA. These are all the compounding problem. How will you solve this? Any idea? I'll give you 2 minutes time. Do you get the point? If one side is affected, okay. If two sides are affected, you go to next. Okay. What is the problem here? Length of DE and bearing of EA affected. Length of, so this is pointed E, length of DE and bearing of EA is affected. How will you solve the problem now? So you got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You have not length of DE, you have not measured the length of DE. You have measured the, you have not measured the bearing of EA. Okay. Right. Now you look at the figure and try to solve the problem. How will you solve the problem? At least one. Okay, what I will do is I will join AD. I will join the line AD. Can I find out length of AD? How do I find out length of DA? How will you find out the length of DA? I know bearing of AB. I know bearing of BC.
Sir,
I know bearing of
sum
AD.
of the sum of all. Sir, this is ADCB is a closed traverse. So from that we can find the
DA becomes a closed traverse wherein DA is the omitted measurement. Okay. So I can find out applying the principle of this. The same principle, is it possible for me to find out what is the length of dA? Length of dA is known. Bearing of dA is also known. Okay. What I omitted? Length of DE I omitted. Length of DE I omitted. So what is the bearing of DE I have taken? So what is that I can find out here? I can find out angle alpha. Angle alpha.
Yes, sir.
Yes. Because I know bearing of DE. I know bearing of DA. So I can find out what is the included angle alpha. Is it not? Alright. So I know bearing of AD. What is the bearing of AD? What is the bearing of AD? Bearing of DA plus 1A plus or minus 180 we get a bearing of AD. Am I right? So I know what is the bearing of AE because length only I have omitted. Okay. Right? So I can calculate what is angle gamma. Alpha is known, gamma is known. What is beta?
180 minus alpha.
180 minus alpha plus beta. What is that? You know alpha, you know beta, you know gamma, you know dA, you know what is DE. How will you solve that? DE.
Sir, cosine rule.
Sine rule. Sine rule is very simple, na?
Yes, sir.
Okay. Length is known, angle is known, one side is known, right? So what is known? I don't know what is DE. Length of DE is unknown. Length of EA is known, na? Length of, so bearing of DE I have taken. So I have not taken length of DE. Okay. But EA I know. So pi by sine alpha. Okay, or D, small d. I can opposite to D is D by sine alpha equal to E by sine beta. Am I right?
Yes, sir.
D. This side is D. This is D. This is E. And this is A. Okay. So you have got a triangle. Small side is, this is A. This is E. Closing line is E. Okay. Closing line is E. And EA is D. D is known. D by sine alpha. Okay. So can I calculate this DE? Right? DE can be calculated using that. So I can solve the problem that way. Is that okay to you? Right?
Yes, sir.
Okay. So I'll repeat it again. So what I do is the length of the bearing of DE, the length of DE and bearing of EA are omitted. The condition is the length of DE and bearing of. So I know what is the bearing of DA. So what I do is close the survey, split it into two parts, join AD, DA become a closing line. So I'll be knowing what is the bearing of DA. I know what is the bearing of DE. I can calculate what is the included angle alpha. Similarly, I know what is the bearing of AD. Okay. And I know what is the bearing of, so I can calculate gamma. So beta can be calculated using the triangular principle. Alpha beta plus gamma equal to 180. Use the sine rule and try to solve the problem. Is that okay? Is that okay? Right?
Yes, sir.
Length of DE and EA are omitted. So length of DE, length of DE and EA are omitted. Both the length, I'm not able to find out what is the length of DE, but I can calculate from the bearing, I can calculate alpha, beta and gamma. Okay, I can calculate alpha, beta and gamma. Okay, why? How? Because I have taken a bearing. Okay, I have taken a bearing. So alpha, beta, gamma, the same sine rule, I can use it and then find out what is the length of DE and length of EA. Okay, length of EE. So omitted measurement. What is the first case? One side is affected. What is the second case? Bearing of one side and length of one side omitted. Third case, length of two sides affected. Is that clear to you, all of you? All the three cases?
Yes.
Yes, sir.
Right. Then comes typical case. Bearing of DE, bearing of DE, and bearing of EA omitted. I don't know what is the angle. Okay. I don't know what is the bearing of DE and bearing of EA is omitted. Then what is that I have taken observation? I have taken observation of length of DE and length of EA. So length of DA is, I calculate, assuming it as a closed traverse joining A and D. Okay. Is that okay? Then how will you solve the problem? So think of it. We will see the solution in the next class. Okay. Or shall we continue? Shall we continue? Okay. What is the solution for this? Hello? One?
So we can use cosine rule, sir, to find the individual angles.
Ah. Is a cosine rule.
Yes, sir.
Uh-huh. So I'll give you a solution for this. Bearing of D and EA are affected. What is that delta I put?
Area of triangles.
Yes, sir.
Area. Okay, area is equal to what? Area is equal to. So what is this side? This side is small d, and this side is small e, and this side is small a. So what is that we know is A, D, E. So perimeter of the traverse is A plus D plus E. Semi-perimeter is half of A plus D plus E. So you know formula S into S minus A into S minus B into S minus C is equal to area of the triangle of this. This formula is very familiar to know. All of you know the formula, this formula. Square root of S into S minus A into S minus B into S minus C, where S is equal to half into A plus D plus E. Okay.
Heron's formula, sir.
Yes, sir?
Heron's formula.
So same thing, delta is equal to half into A into included angle. Okay. and equal to CD. So it is a now it is a parallelogram. No? It's a parallelogram. Right. From CD I draw a parallel and equal to DE. Right. So what happened? Now these adjacent side, this side which is affected, this has gone to this. Right. Now this is the closing error with all the data, because you know the bearing and length of this line. You know what is the bearing and length of this line, but you may not be. Case they are adjacent, the adjacent sides are affected, but here it is not a case. So what is that? The length or bearing of BC has not been measured, and this EF is a affected side. So this
Sir.
Yeah, please.
Sir, but E dash E is not parallel to BC, no, sir.
Not necessary. Not necessary. No, it's a parallel actually. It's a parallel. This line is parallel to this. You are transferring this point, you are transferring it to this. You know what you do is you draw a line at B parallel to CD and equal to C. So D gets shifted over this point. Okay. So you know what is the BD? BD is parallel. The length of BD is equal to the length of CD, and the bearing of BD is equal to bearing of CD. Is it okay?
Yes, sir. Got it, sir. It's a parallelogram.
From here, you draw a parallel line parallel to this point, DE. So DE dash is parallel to DE. So you strike at point D, right? So what happened? Then you construct a parallelogram. This is also parallel, no? So two parallel lines. So you get that. So this what happened? Now these get transferred. This point BC get transferred to E dash E. So you got this and you got this. These two sides are made adjacent. So use the other data and solve the problem. So you get a E dash F is the closing error. E dash F, you will be finding out what is the bearing and the length of E dash F. Then it is a simple triangle E dash E F. I think F is hidden over there. E dash E F. Then use the principle of your triangle and then try to solve the problem. Is it okay? So with that we complete the chapter on omitted measurement. Normally, this advantage of online classes, whether you people have understood or not, which I may not be knowing it, only very few people react. Others, are you active listener or a passive listener? How do I know that? Okay. Right. Some classes should have some quiz-like thing, so that random questions are being chosen, and randomly I will call a people and then try to answer it. Okay. So most probably tomorrow may you just brush up this and come back. I'll ask you to work out on problem in the class itself. I give a statement and then you try to work it out. That I just closed down today. Right. Or now you work out. Can I type a problem? You can work out now. You are free.
So no, sir. Mechanics of solids is just pre-bonding to your periods.
It's at 11:30 only. Yeah?
No, sir. Actually,
11:30 is my class. Taken 1 hour ahead. No.
no, sir. Since you took the class, I told him to start his class at 11:30. That's why.
Okay, then in that case I'll just prevent it. Okay, fine.
Okay.
I just close down.
Thank
Thank you. Anybody is recording it? All this I forget to record it. At later stage you may not require it. Do you require a recording when all of you are present? Really?
Yes, sir.
Huh?
So can you share the PPT, sir?
That I always do it because it's not my property. I just copy down from somewhere else. No? Right. Okay. Bye.
Thank you, sir.